So we're going to be working on uniformly accelerated motion. This means that the velocity of the object is not being changed by itself or anything else except for gravity. You've been given a velocity equation and a location equation. You don't need to memorize either one. If you need them, they will be provided, except for this assignment today. I chose to leave gravity open in the equation because this formula will work on the moon or Jupiter or Saturn, any place where the gravity is different than that on Earth. So for this assignment, we're just talking about Earth, so you can assume that gravity is going to always be 9.8. So that 9.8 is going to go into the velocity equation as the coefficient of t. It's going to go into the position equation as multiply it by 1/2, and then it will be the coefficient of t squared. So the initial velocity is the speed at which the object begins its motion, and that's your constant in your velocity equation, or the coefficient of time in your standard in your position equation. And then finally, we have our initial location, which would be if something is tossed off of a building. The initial location would be the height of the building, for example. So our first question, where it's hit directly upward from a point 2 meters above the ground, that is our initial location. So S0 equals 2, and it has an initial velocity of 45. That's your V sub 0. So V sub 0 equals 45. So when will the ball reach its maximum height? Now, the maximum height is the vertex of the parabola. This particular parabola opens down, which means that the vertex is the maximum value. Now, we can find critical values by setting the derivative equal to 0. Remember, velocity is the derivative of the position. So the first thing we want to do is find our generic velocity equation, which is negative 9.8t plus 45. And our critical value is going to be when the velocity equation equals 0. So when does negative 9.8t plus 45 equals 0? Well, it happens when 9.8t equals 45. So we're going to divide 45 by 9.8. So 45 divided by 9.8. So at 4.59 seconds, the ball reaches its maximum height. Now for part B, they want to know how far it's going to travel. You have to use the position equation for that. So we're going to plug all that stuff into the generic position equation, which is negative 1/2 of 9.8, which is negative 4.9 t squared, plus the initial velocity, which is 45t, plus the initial location, which is 2. So here's our generic equation. We want to know what that height is going to be at 4.59 seconds. So we're going to insert 4.59 seconds into this. So negative 4.9 times 4.59 squared plus 45 times 4.59 plus 2. Now, make sure that you put a negative in front. The first time I calculated this, I forgot that negative and got a completely wrong answer. So negative 4.9. Okay, and now I'm going to insert the answer, and I'm going to square that. Then I'm going to do plus 45 times, again, insert the answer, and then I'm going to do plus 2. So 105.32 meters is the highest that it goes. So that is approximately 105.32 meters. Okay. Now, how long will it take for it to pass its starting point? Well, remember the starting point was 2 meters. So we want to know, when is the position going to be 2 meters again? So set our generic ST function equal to 2. So remember, its starting point was 2. Okay, so we want to know when it equals 2. Ooh, I don't know why I just put an equal sign. That should be plus 2. Sorry. So plus 2. Well, first off, you're going to subtract 2 from both sides, which is going to make that equal 0. So this whole function, negative 4.9 t squared plus 45t equals 0. Since there's 2 terms and they both have t in it, you're just going to pull a t out. So this is t times negative 4.9t plus 45, and the whole thing equals 0. Now the first solution is going to give you t equals 0, which means you were at your starting point when you started. So that one, not so helpful. Okay, this one is when t equals 45 divided by 4.9. So 45 divided by 4.9 is 9.18. So at 9.18 seconds, it passes its starting point. For D, they ask us what is the velocity when it passes its starting point. That means we're going to plug 9.18 seconds into the generic velocity equation that we found, which was this guy here. So this is our generic velocity equation. We're going to use that equation down here, but we're going to replace t with 9.18. So negative 9.8 times 9.18 plus 45. Okay. And that, so negative 9.8 times that answer plus 45. So the velocity is negative 45. So that's, and actually it's not approximate if you use the whole answer. So negative 45 meters per second. Sorry, meters per second squared, because it's velocity. Okay, so there's our answer for that part. How long will it take for the projectile to hit the ground? Now the ground is 0. So we want to set our position equation, instead of setting it equal to 2, like we did here, we're going to set it equal to 0. Because we don't want to know when it hits the starting point. We want to know when it goes 2 feet below, or 2 meters below the starting point. So 0 equals negative 4.9 t squared plus 45t plus 2. And for this one, just use your GDC. There's no reason to do the quadratic formula and figure out the actual answer. Just put it into your GDC. So y equals negative 4.9x squared plus 45x plus 2. I want to know when that equals 0. So go ahead and graph it. So it is a negative function. You can see that it's crossing here at 0, because that's nope. It's crossing here. I'm somewhere after 9. So go into table set. Start 8.5. Oh, sweet. Okay. 8.5 and 0.1 is going to work fine. So I want to know, so somewhere between 9.2 and 9.3, this graph crosses from positive to negative. And it looks like it crosses closer to 9.2. So I'm going to go back into table set. I'm going to start it at 9. And I'm going to change my delta table to 0.01. So I have a more accurate idea of when it crosses. So now we just arrow through. My numbers are getting smaller, but they're still very positive. There we go. Okay, so 9.22, it's at 0.35, and at 9.23, it's at negative 0.01. So it seems to be closer to 9.23. But at this point, we can just say 9.225. Okay, so at approximately 9.225, so T is approximately 9.225 seconds. Okay, that's close enough. And then F, what is the speed of the projectile at impact? Well, the speed is your velocity at that point, but it's the absolute value of your velocity at that point, because velocity indicates direction, speed does not. So we're looking for the absolute value of the velocity function, which is the first one that we circled, negative 9.8 t plus 45. So we want the absolute value of negative 9.8 times 9.225 plus the initial velocity, which is 45. So the absolute value of that. Okay, so we're going to exit out of here. We're going into math. Number. Absolute value is the first one. And that's negative 9.8 times 9.225. And we're adding 45 to that. 5. And now get out of your absolute value and hit enter. So 45.405 seconds. So speed is approximately 45.405 meters per square second. There you go. All right. So you have a homework hint for number 9. It's a piecewise function. You are going to have a definite integral that's part of it. And then the second part, you're going to use a variable for the last for your endpoints. In order to make the object's motion continuous, you need to make sure that your value for the C is the same number that will make those have the same point where the second part starts and the first part ends. You want it to be continuous. And then once you figure that out, you find the first part. They're asking you to find the area of the first part and the area of the second part and add them up and set it equal to 4. All right, good luck.